Today I'm looking at the Shapeoko HDM. We'll get it unboxed, set up the enclosure, some accessories, and get it prepared to do some work, so stick around. Alright, so the HDM arrived 4 months after I ordered it. 4 months, maybe a week or so. And here it is, in all of the free available space of my shop. It consumes it like no other machine. Taking off those straps, we pull off the lid, and you can see it's the only packing material are really the boxes of accessories that come with the machine. And the machine is pretty hefty at that. In this case, I've got the pallet up on a couple furniture dollies that allow me to move it around the shop and rotate it to position it as needed. Now there are several boxes inside this pallet. I'm pulling those out. We'll talk about the contents of those a little bit later. But spinning it around and getting my first look at the HDM, it's rather impressive. I would say it's around 240 pounds, I think. Don't quote me on that, but you can see the new controller enclosure there. It's all pre-wired. There's really nothing to do other than you know, those slats that are missing on the sides are missing because they're actually screwed down to the pallet. So the machine cannot move from the pallet until you remove those screws. Now, Carbide3D has some great documentation about creating this and unboxing this. So this video is not for that, but it's going to show you, you know, my first impression, as well as get a first look at this 1.5 kilowatt, 110 volt spindle, and the structure and machine in general. The only branding really on it is that Carbide3D logo on the front of the ball screws. I'm just kind of looking at the drag chain and the extrusions and that sort of stuff, the NEMA 23s, the HD16 linear rails, and the 16 millimeter ball screw as well, which is hefty and super solid. So that said, now we got the controller. The controller looks pretty much like a DIY kit, with the exception of the Warthog controller board in there. So this enclosure looks like it was laser cut or milled for the VFD to fit in there properly. So that was kind of an interesting take, but just a standard power supply. The VFD is kind of nice because this control panel pops out. You could run it to the front of your machine, but because the Warthog automatically controls everything, you shouldn't need to do that, but just know that you have some options. These VFDs are really flexible, and you'll see a little bit later how we can benefit from that. The backside, the VFD vent and the power supply exhaust, and an IEC connector and power switch there. Now just kind of looking at the X-axis drag chain, this thing's huge. It's got a lot of available space so that we can run some additional lines through there, and I'll show you how I'm going to use that a little bit later. But after the X, then it goes into the Y drag chain as well, and out the rear where it connects to the control enclosure. Now, if you just want to put this on the table, you're probably really close to good to go, right? So now, over on the table, let's look at these extra boxes. So these extra boxes, we've got the tease nuts, basically heavy-duty T-slots, and a general purpose hold down clamping set, which you can buy from Carbide3D. They just kind of threw that in as part of this. I'm not sure who would buy an HDM and then want to use these on the machine, because the HDM's intends, you know, is structured to mill hard materials, and these aren't great for that. They do offer some better hold downs that I think you should probably invest in or check out, and you'll see how we deal with that a little bit later. Also, it comes with the Sweepy 2.0. Now this has a few bells and whistles that I didn't expect. So it's got obviously a couple different adapters for your vacuum hose to connect to it, and it's got a couple different shoe options as well. Now this fits on the 80 millimeter spindle. We pop off the shoe, and it's got a brushless pickup as well. I think that's for metal. If there's another reason you can think of, yeah, leave it in the comments below. So looking forward to using that. It's clean, and the magnetic connections make it easy to use. It mounts directly to the spindle. Next, we have a couple other remaining boxes which are unbranded, and I suspect that those are going to be parts for the machine. and they are. So additional hardware to connect the slats, as well as you know, a 3-flute flat carbide end mill, 1/4 inch, a couple ER20 collets, both 1/2 inch and 1/8 inch. The 1/4 inch collet is already pre-installed on the spindle itself, and then a couple spanner wrenches. Those spanner wrenches are going to be for the chuck and spindle itself to remove the collets, and of course the power supply cord IEC connector for the controller. Lastly, we have the fun stuff. That's going to be a bit setter adapter, the Warthog controller dongle, the bit setter itself. This is a pretty heavy duty version, which is setting the tool length, of course. This bit setter will be mounted in some arbitrary corner of the machine and allow you to measure your tool lengths on tool changes, as well as a USB-C connector for the Warthog dongle. And again, this is a T-slot adapter for the bit setter. So those accessories aside, we also have this industrial CW3000 chiller, which really common chiller available on Amazon and AliExpress. I've seen it lots. My previous Shapeoko setup, I just used a custom designed cooling circuit, but this should prove to be a little bit easier to manage. So this is my first look at the chiller itself as well, and it does provide some capabilities that we'll leverage a little bit later. Getting it out of the plastic and looking at the front, we've got a readout for the temperature as well as a power switch. On the top, we've got the cap for filling the fluid in there. Pretty basic. On the side, lots of louvers for pulling air through, and I believe the other side has louvers as well for exhausting it. On the back, we've got a water inlet, outlet, an alarm output, as well as an IEC connector for the power. All right, now that I've had a chance to share the HDM as it looks when it arrives, all the accessories that come along with it, in order to use it in my shop, I'm going to need to build an enclosure. That'll help contain the dust and particles, and it needs to have good visibility and accessibility. So in Fusion 360, I designed an enclosure that met my requirements. So let's dive in and talk about that. In Fusion 360, I designed my enclosure based on a 3/4 inch Baltic birch and a 1/4 inch acrylic cast plastic. I included some pass-throughs for wires, as well as a back door for milling long objects, an exhaust port on the left-hand side, and these heavy acrylic 1/4 inch door to give you free access to the machine. So my previous design, I had 2 doors. It was a bit of an encumbrance and always got in your way. This large front door will have gas struts to raise it and hold it out of your way. All of the acrylic are 1/4 inch thick, and they have notches around the perimeter of the acrylics to screw them into place, into countersunk areas in those parts. So when it was good to go, it was time to send it off to a shop. For that, I manually nested all of the parts for the enclosure on 2 sheets of 3/4 inch Baltic birch plywood, as well as 1 sheet of cast acrylic 1/4 inch. And so all of these windows, you can see they have notches all the way around it. That's where the screws go in to hold them in place. And this large square down here is the front door, which will need to be bent. Generated a couple drawings, sent those off to a shop, and then got the parts back. With that, the first thing I did, the cuts were really clean, didn't have to do a lot of sanding, but I did use a sanding sealer on everything. That was the first step. Kind of get that grain to raise and sand it so that it'll save me some coating a little bit later. Once the sanding sealer had dried and I sanded it one time around, next was to hit it with latex acrylic that I used to paint them all jet black. All of these parts were just painted with the same foam roller and touch up with a small detail brush. Even though I live in Florida, it was around 50 degrees. January is still pretty cold in Florida. So it took some time to dry. Once they were dry, then it was just a matter of dropping in those windows and screwing around 16 screws into each one to hold them in. Now all these screws are on the inside of the enclosure, so the outside looks really clean. These 1/4 inch cast acrylic panels are solid. They're going to protect you from debris and flying materials, so that's a good thing. Screwing in the left side and then the right side, and then the back as well has a window with the same inset or window inlay, and then probably about 20 screws to hold the rear window in as well. The lower section there is the door that you'll see a little bit later. So with the machine sitting on the base, I began to build the enclosure around the machine. It's just so heavy, I don't think I could raise it and lift it in there if I built the enclosure before moving the machine. So my plan and strategy was just to build it up around the machine. So you can see I've got it sitting on a couple Harbor Freight workbenches. All right, next up, I needed to disconnect the controller because I want to route all my wires through those ports. And oddly enough, none of the wires are labeled. So I'm not sure how they did it. Maybe they just did them one at a time. So all of the motor power, VFD, end stops, LEDs, power switches, you name it, they're all just in there unlabeled. So I used my label maker to tag everything so that I could be sure to get it exactly the way it was, not introduce any problems that may be a result of plugging things in the wrong places. So with that, this picture is really to kind of, for my own self-reference. Before I started unplugging things, I wanted to make sure that everything was labeled correctly and there was no question about, where things went. And then it was a matter of unscrewing the Warthog board to gain access to a couple connectors beneath the board, as well as cut away the zip ties and begin to disconnect all of the wires. So once the wires are disconnected, then I'm feeding them out of the grommet, and that will give me all the raw wires that I'll be running through the back of my enclosure. 3 or 4 wires for the VFD that also need to be connected, so it's important to pay attention to the order. Otherwise your spindle may go the wrong direction, those sort of things. FYI, just underneath that Warthog board, there is a VFD controller board. Now, these inserts for the pass-throughs were just bought off of Amazon, and I'll leave links to all of the components that I used in setting up the machine. So with all the wires pulled out of the controller, I'm going to run them all through this back access port. And it's just a little time consuming. Make sure you don't pull any wires unnecessarily or stress them at all, and just kind of feed them through there. It's a slow process to do it right. As well as the cooling lines will also be coming out of here. And of course, zip ties to clean everything up. So with all of the wires through the rear port, I can begin to feed them back up into the controller, which was a tedious process. These grommets are a little smaller than they probably could be to make it a little bit easier, but they also keep the dust out, so it's a trade-off. So connecting the VFD, getting those lines back exactly how they need to be, most critical. And then the end stops and power supplies for all your steppers, getting the Warthog board back down in there. There is a connector down on that VFD controller board, which was kind of tricky to get at. Once that's plugged in, drop in the Warthog. I'm just using a hex driver to mount that board down. Once complete, connecting all of the steppers for the X, Y, 2 Ys, and a Z, as well as the end stops for all 3 axes. And there's a power switch, LED, and we're good to go. Of course, clean it up with some zip ties as well, just to manage the wires within the enclosure. Now it's time to put the sidewalls on. Now for that, these were all pre-drilled from the shop that I had cut these out, but they didn't go into the ends of the other laminates, so I was drilling them out and then running 2-inch screws into them. So you can see me running through the pilot holes to drill the full length so as to reduce the amount of pressure that those screws would cause. Once the right side was on, went over to the left side, did the same thing, drill through the pilots or the pilot holes. This was a a long weekend project. But these are things that you know, I needed to do in my particular shop to maintain the organization and cleanliness of it across all the different disciplines. Lastly, put that top section on. It's got about 6 screws on the sides and then about 8 on the back. Since this was all CNC milled, the dimensions on it were all perfect to the Fusion design, so it was great. In that regard, I didn't have to worry about tolerances and gaps, which is why there was a lot of importance on doing that planning in Fusion before I paid to have these things milled out. Now, this is where I'm going to mount the controller on the side panel there. And so I drilled a couple pilot holes, and I think they have a couple M5 screws that go into mounts in the back of that enclosure. Once that was mounted, things are starting to come together. It's time to, you know, clean these wires up, make them a little tighter so that nothing gets snagged on them. And if they do, then the zip ties are going to help out with preventing, you know, problems. My favorite tool is always the zip tie gun. And then next is to lay in this door stop. Now, this door stop is responsible for you know, seating the door flush. Now the door has a frame, and while I'm at it, I screwed in the back door and put a barrel key lock to allow me to lock it into place. Next, it's time to fill up this chiller. I just used some Prestone. I used 2 of these to fill it up, and I used a cup as a funnel, which didn't work out too great. It started to leak around the back, of course. Not my best idea. All right, that said, we filled these up with 2. This is a 2.5 gallon unit, so I think I used the 2 gallons of that, and then I put a ½ gallon of water in there just to top it off. And then with that, we hit the switch, turns on. It sounds like a humidifier. I believe this is also only in Celsius. I don't see a way to change it to Fahrenheit. And that lovely green Prestone antifreeze color comes through, and the bubbles work their way out over time. So on the back of that chiller, there's a alarm output. It's a 3-pin connector. Now the interesting capability of that is to use it for something, and I'll show you how I'm going to use it. So one of the pins is common, the other 2 are green and red. So you can use them for, in my case, like a light tower, and that's what we're going to do. So I wired up 3 conductor wire to the respective pins. So black is the common, red and green. So red would represent an alarm state, and green would represent a good state. So we can use that to add some intelligence to the machine. And this is one of those add-ons that's not necessary. You don't need to do it. But for me, you know, it adds that functionality that's going to improve the reliability of the machine. So that just screws in through a connector there into the back of the chiller. It's basically a relay. Your common's going to switch between red and green, whatever you feed into it. Originally I had those cooling lines over on the left-hand side. I routed them to the right-hand side because that's where I plan to keep the chiller. And then, of course, clean it up with those zip ties to ensure that we're all organized and good to go. Now, I run those 3 wires over here to the VFD. Now, the VFD has a relay in it as well. The reason I'm going to use that is because that's going to provide some functionality to my light tower. I've added a light tower on the back. So green is going to be good to go. Yellow is you've turned on the machine, but you haven't turned on the chiller. So if I run over here, turn on the chiller, then it goes to green. Now, if you don't turn on the chiller and you turn on the spindle, then it's going to go to red and make a loud beeping sound. So once that's done, I also added a mister. So I'm sure you're familiar with that. I just use this bike bottle, this little 1/8" hose, and I'll typically use a 10% alcohol water mixture. The next part is the hard part, and that's the front door. So using this stovepipe, my plan was to heat the door, melt it around that stovepipe, and that stovepipe's really just going to support it. Now you can see the door frame. that's already installed, this curved piece. All of the stuff I'm pointing out is the frame of the door. That's part of the door that moves. And that basically structures it to be more rigid, even though you have a 1/4 inch acrylic. The first thing to do is to put that large flat sheet up there and mount it to all of the hinge points. Now, my thought was, I'm going to mount it to these hinges, and then I'm going to heat it up and bend it around that stovepipe, and everything's going to work perfect. I always underestimate the amount that is going to carry through. So the fact that I'm using that blue tape, masking tape, that ends up leaving some impressions in the acrylic, which it's so sensitive. You really have to have a polished form or forming buck, whatever you want to refer to it as, when you're doing these thermoplastic bends. So I'll probably learn from this one, and the next one we'll be sure not to do that and use something a little more rigid, because that stovepipe ended up, even though it was bent, ended up not being very strong for this purpose. So I started with a heat gun and ended up using this blowtorch because the temperature is just so much more rapid with that. Now the hardest part, as I'm bending this down, is maintaining the temperature of the acrylic across it by myself. If I had some heating elements, if I was going to reproduce this, I would have a better setup. But in the end, it didn't turn out too bad. So once the plastic's bent, it's then mounted to that black frame that I pointed out earlier. But having that door open, it's just great in terms of providing extra headroom to access the machine. Now, to finish off the machine, I had this 32-inch monitor. I added a fanless mini PC to the back of it. I run Carbide motion on that, and that runs out HDMI into that monitor. That gives me a huge heads-up display on top of the machine that I can manipulate and load and do all that fun stuff. And if you're just milling wood and stuff, which I'm not sure why you buy an HDM if that's all you're doing, I've also included like the bit 0, and that allows me to probe really easily on my material. And you can see the T-slot connection with the bit setter in place, the wireless keyboard. On the front, the only other minor change I made is I labeled all the buttons. They don't have any information about them. The lockout will enable or disable your spindle. The blue light is the power button, and the top is a feed hold, which will allow you to temporarily pause your operation. If that's all you're doing, then I'd be good to go. But I bought an HDM to mill aluminum, and for that reason, a fixture table is in order. So if you want to go that extra mile, like I did, the next step is to go to Saunders Machine Works and order their aluminum or fixture plates. And what you see here is what we're doing. And so in order to install that, you need to remove all of your wooden slats. Now, this version that's available at Saunders Machine Works will mount directly into the T-slots. And I'm setting up with a central configuration, but there are alternative configurations. You can move them to the outer regions, or rotate them 90 degrees to get a little bit extra X. But you want to keep in mind that you will be losing about 1.5 inches on either side of these fixture plates if you set them up in the orientation that I have them configured in. With those fixture plates, this is a 1/2 inch fixture plate. You can also get the mod vices, as you see here, with reversible heads, as well as soft jaws and all sorts of accessories to improve that. The lower left-hand corner, you can see I've got plugs. I have to buy more plugs. That'll keep all the chips out of your threaded holes. So that said, this is going to offer a much better fixturing solution for the HDM and be able to leverage it to its full capacity. Now with that, the enclosure, the setup of the machine is good to go. You see we have the exhaust line in there. We've got the monitor up on top, and it's time to start milling stuff. So in the upcoming videos, you'll get a chance to really see me put this to use. I've got some projects that will rely on its capabilities, and I look forward to sharing those with you. All right, so there you have it. That's my setup with the HDM. I think we're good to go. I'm so glad to get through this. This has been about a 3 to 4 week process for me to get all the parts, mill the parts, set up the machine, configure the machine, build the enclosure specifically. as well as the Saunders Machine Works fixture plates, were 99% good to go. Granted, you can use this out of the box, just put it on your table and start milling, but I need to go that a little extra distance to be able to meet my expected needs down the road. With that said, if you enjoy this video, give it a thumbs up. Future videos, we're going to be milling more stuff on this. We'll be pushing it to its limits, and I'll just be sharing as much content as I can on the HDM that I was hungry for. So hopefully that'll help you guys make a decision on whether or not this machine meets your needs and what you can really expect from it for a 1.5 kilowatt spindle. That said, in the meantime, be safe, have fun, and I'll see you next time.
Hey, if you like the video, please subscribe to the channel. It's how we're building the community. Also allow me to bring better content. Also check me out on these other social networks. There's lots of cool stuff there too.